Infinite clipping is one type of distortion effect. Here, the amplitude of the input signal is stretched out to take on either the maximum amplitude value or the minimum amplitude value. In this case, if the amplitude is positive, we're going to round its value up to 1. If the amplitude of the input signal is negative, we're going to round it down to -1. We can implement this effect in several different ways. First, we could use conditional statements. Second, we can use a built-in function to MATLAB called sine. So let's go ahead and look at how we can create our own infinite clipper. Here in MATLAB, I'm going to demonstrate a couple different ways to perform infinite clipping. The first method will be based on creating our own user-generated function, very similar to what we did before with half-wave rectification. In fact, what I'm going to do is start by opening up this M file, selecting and copying the entire contents of this file, and then opening up a new M file script. I'll paste in these commands that we had in the other function, except this time we don't want to perform half-wave rectification. I like to perform infinite clipping. So I'll change the name of this function to infinite clip. We still want to pass in a signal, process it, and then pass out the other signal. I'm going to change this comment, say infinite clipping. We can still use a loop to go through and analyze each individual sample in our signal. However, we want to assign different values to the output signal. So first, if our input signal is anything greater or equal to 0, then we want our output to be equal to 1. Otherwise, if our signal is negative, we want to set the output to be equal to -1. So we can go in and even hard code in these values. Our output is equal to 1, or in the other case, -1. And that's all we need to perform infinite clipping. I'm going to save this file by the same name, and we can go back over to our distortion test script, comment out half-wave rectification, and test our new function. Going to use this sine wave as our input signal. That'll be helpful for us to see what the effect is doing. So I'll run this script to see the plot. Our input signal is in blue. That's our sine wave. Then red is our output processed signal. We can see that anytime our input signal in blue is greater than or equal to 0, it gets rounded up to 1. Anytime it's less than 0, it gets rounded down to -1. In fact, this is a great way for us to take a sine wave and process it and turn it into a square wave, a different type of test signal. Next, let me move on and show you a second way that we can use to perform infinite clipping. This will be based on using a built-in MATLAB function. I'm going to demonstrate here in the command window a few things about this function. The name of it is sine, S-I-G-N. If we put in a value here that's greater than 0, 0.5, it will return for us a 1. Now the purpose of this function is actually to help us figure out if we have positive or negative numbers. So if we were to put in negative 0.5, will tell us that we actually have a negative number. And so the value that it returns is -1. So in fact, even if we didn't want to write our own function to do this, we could write that our output is equal to the sine of our input. And this function will handle an array and return an array of the same size just by processing each individual element. So I'll run this script. We can see that it gives us the same output. So there are a couple different methods that we can use to perform infinite clipping.